Right. I hope you guys can see me. Right. So, a very good evening, everyone. We'll be starting our presentation sessions now. Please raise your hands and we'll be going by the order of raised hands. Right. Yeah. So, first we have Prateek with us. Yeah, Prateek, you can share your screen.
So,
Yeah, reshare.
is it visible, sir?
Yes, it's visible.
Uh,
Right. So, from which group are you?
ML and deep learning?
Okay. Okay. And the presentation is scheduled, right?
Yes.
Okay. You can start, Prateek.
Good evening, everyone. My name is Pratheek Shetty. I had received the task diagnostic, predictive, and prescriptive models. Build a predictive model to predict the math score of a student based on other variables. Use supervised learning algorithms. Evaluate the model using appropriate metrics and use feature selection techniques to identify the most important features for predicting the math score. Consider a situation. Imagine a person driven by the desire to improve student performance, working on a data set so that he could give back good feedback to students that might help them score better grades. He examines historical academic records, seeking patterns and insights. However, without the aid of predictive modeling, his efforts would feel like an uphill battle. The person would struggle to identify. The person would just have to watch as the students would continue to struggle. Their potential would still remain untapped. The lack of predictive modeling would prove detrimental and hinder progress. In a sentence, predictive modeling is vital for making accurate predictions and informed decisions based on data, optimizing outcomes in various domains, including education, finance, healthcare, and marketing. Predictive modeling plays a crucial role by harnessing data driven insights to anticipate future trends, make proactive decisions, and optimize outcomes, leading to improved efficiency, effectiveness, and informed decision making. Need for predictive modeling. In decision making, informed decision making through data analysis, pattern identification, and future outcome prediction for strategic planning and resource allocation. In risk assessment, it's crucial for risk assessment by identifying potential risks and their likelihood, allowing proactive mitigation in fields like insurance, finance, and healthcare. In customer behavior analysis, predicts customer behavior, preferences, and purchasing patterns, enabling personalized marketing strategies and improved customer experiences. In resource optimization, it optimizes it optimizes resource allocation by forecasting demand, supply, and resource utilization, streamlining operations, reducing costs, and improving efficiency. In forecasting and planning, accurate forecasting for sales, revenue, market trends, and economic indicators aids in planning, goal setting, and adapting strategies to capitalize on opportunities. The contents of this task were importing libraries, dataset handling, data exploration, descriptive statistics, data visualization, feature selection, algorithms, predictive modeling, and metrics. The libraries used were Pandas, NumPy, Matplotlib, Cbon, sklearn.tree decision tree regressor, logistic regression, random forest regressor, metrics, and voting regressor. Pandas is a data manipulation and analysis library with efficient structures and functions for structured data. NumPy is a numerical computing library with support for large arrays and mathematical functions. Matplotlib is a plotting library with MATLAB-like interface for visualizations in Python. Seaborn is a statistical data visualization library for attractive and informative graphics. Now, the other 5 libraries is a part of sklearn library. Here, decision tree regressor is a class for creating decision tree regression models. Logistic regression is a class for creating logistic regression models. And similarly, random forest regressor is a class for creating random forest regression models. Metrics provides functions for evaluating models, and voting regressor is a class for creating ensemble models that combine predictions from multiple regressors. Dataset. The dataset contains information about students' performance, including their math score, reading score, and writing score. The dataset has a total of 1,000 rows, which implies there are 1,000 students in this data, and 8 columns. The dataset aims to investigate the impact of factors such as gender, race or ethnicity, parental level of education, lunch type, and test preparation course on students' performance. Data exploration. The dataset contained no missing values, and all the columns in this dataset were of object data type except for math score, reading score, and writing score, which were of int data type. Descriptive statistics. In these columns, in gender, group A, group B, group C, group D, group E. In parental level of education, there was some college, associate's degree, high school, some high school, bachelor's degree, and master's degree. In lunch type, there was standard and free or reduced. In test preparation course, there was none and completed. This is a data visualization part. I'll explain this in the demo, but yeah, the top left is a box plot of math score versus gender. On the top right, there's a math score versus race or ethnicity. On the bottom left, there's a math score versus lunch. In the center, there is a math score versus parental level of education. And bottom right is a math score versus test preparation course box plot. Feature selection. Feature selection is the process of choosing relevant features from a larger set to improve model performance, reduce overfitting, and enhance simplicity. Here I've used backward feature selection. Assume we have the following variables. X1 is age, X2 is experience, X3 is education level, and the target variable is Y, which is salary. Now we fit a model for using all 3 of these variables. We calculate the significance level for each feature and remove the feature with the highest p-value. Assume, for example, x1 here has the highest p-value. X1 is removed from the next iteration, and this process again followed iteratively until we get the desired number of features. Algorithms used. Supervised algorithms. Supervised algorithms are machine learning models that learn patterns and relationships between input variables and their corresponding output labels based on labeled training data. They're used for classification and regression tasks by leveraging known input-output pairs to make predictions on new unseen data. Examples of supervised algorithms are decision trees, which are build a tree-like model of decisions based on feature values to predict categorical or continuous outputs. And random forest, which is an ensemble of decision trees that combines their predictions for improved accuracy and robustness. I'll explain one of the algorithms, which is decision trees, because I've used several algorithms. Now, decision tree is a binary tree which has a condition in each node. If this condition is true, that for a data point, the data point falls into a particular child node. If this condition is false for a particular data point, it goes into another child node. These conditions are calculated on the basis of different metrics like Gini index, gain ratio, and information gain. Predictive modeling. I've used ensemble learning. Ensemble learning is a machine learning technique that combines multiple individual models called Bayes learners to create a more powerful and accurate model. The ensemble model makes predictions by aggregating the predictions of its Bayes learners, often using methods such as voting or averaging. By leveraging the diversity and complementary strengths of multiple models, ensembles can improve generalization and robustness, leading to better overall performance. In this diagram, there are several Bayes learners here. For example, Bayes learner 1, Bayes learner 2, Bayes learner 3, which give predictions of prediction 1, prediction 2, and so on to prediction n. The meta learner takes these prediction values as input and gives a final prediction value based on aggregation. Metrics used for evaluation. Here I've used two metrics. One is R2 or R squared and RMSE, or it's called root mean square error. R2 or R squared is an evaluation metric used to measure the goodness of fit of a regression model. It represents the proportion of the variance in the dependent variable that is predictable from the independent variables. R2 can vary from negative infinity to 1. If the model fits the data poorly, R2 can be negative, indicating that the model performs worse than a horizontal line. A horizontal line implies that the prediction is always equal to an average. A value of 0 suggests that the model does not explain any of the variance, while a value of 1 indicates a perfect fit, where the model explains all the variance. Root mean square error, or RMSE as it's known, is a commonly used evaluation metric for regression models. It measures the average deviation between predicted and actual values. RMS, RMSE calculates the square root of mean of the squared differences between predicted and actual values. It is interpretable in the same unit as dependent variable and a lower RMSE value, indicating better model performance. This is my uh, Jupyter notebook. Here I've imported the libraries. Here I've read the data set from the file. This is df.shape. This shows that there's 1,000 rows and 8 columns. And again, like I explained, that data types, all of them are object type except math score, reading score, and writing score, which are int type. Here I've tried to detect missing values, and all of them were 0, which implied there is no missing values in any column. Then I performed descriptive statistics. Each column had different number of categorical variables, like female over here is 518 and male a total of 482, and similarly different categorical variables or number of a number. Here this is a list of all the math scores. What's important here is there are unique values of 81 values, and there are totally unique 72 values in reading score, and similarly there are unique 77 values in writing score. Here the aggregates of math score, reading score, and writing score. Here the reading score has a slightly higher mean value compared to writing score and math score. Oh, here in this data set, correlation matrix doesn't give much details because there are just 3 int type datas, which is math score, reading score, and writing score. But anyway, math score in comparison to reading score has a correlation of 0.817, which is good, as it ranges between -1 to 1. Writing score has a correlation of 0.8 with math score, and reading score has a correlation of 0.954 with the writing score. All these are positively correlated, as I'll show you a bit later. Now this is data visualization. This is a box plot of gender versus math score. Here the conclusion could be that male students had slightly higher scores than female students in maths. Similarly, in race or ethnicity versus math score, you can say Group E and Group D races had a slightly higher math score than the other groups. In a parental level of education versus math score, you can say high school students and some high school parental level of education give lower math scores. In a lunch versus math score box plot, we could give the conclusion that students who had a standard lunch had a better math score compared to students who had a free or reduced lunch. And similarly, in a box plot of test preparation course versus math score, we can say that students who had completed the test preparation course got slightly higher math scores compared to students who didn't take any test preparation course. This is scatter plot of math score versus reading score. Here you can see as math score increases, even reading score increases, or vice versa, like as reading score increases, math score increases. In a general sense, it doesn't mean it's strictly that reading score increases, math score should increase. Similarly, as writing score increased, math score also increased. Feature selection, as I already told, I used backward feature selection. And the selected features I got were reading score, writing score, gender, male, race or ethnicity group E. Here, since except reading score and writing score, all the other features were categorical variables, they gave categorical variables instead of column values as selected features. But since I'd already seen here from these box plots that all columns had some or the other significance with math score, I decided to use all these columns for predictive modeling. In my task, I was told to use predictive race or ethnicity, parental level of education, lunch, and test preparation course. So initially, I made a predictive modeling without reading and writing score. Again, here when you train the data set, there are two features which is important, which is the test size. I've taken 0.2 and random state. Random states give different R2 scores. So I coded a program to get the best random state of 1, which had a R2 score of 0.899. I used decision tree regressor, logistic regression, and random forest regressor to predict math scores here. I got an R2 score of 0.05, which isn't good. It's very close to 0 again. For decision tree, an R2 score of 0.096 again, which is very close to 0. For logistic regression, random forest probably gave the highest of 0.157 R2, but still it isn't very high. It's a poor predictive model. So I performed predictive modeling with reading and writing scores. Here again, I used decision tree regressor, logistic regression, and random forest regressor. And I got an R2 score of 0.75 for decision tree, 0.246 for logistic regression, which is better than the previous example that I showed, but still it isn't great. Random forest regressor probably gave one of the closer ones to 1, which is 0.856 auto score, but it still can be improved. So I created an ensemble method with 10 algorithms which are commonly used, like linear regression, decision tree, random forest, gradient boosting, ADA boost, XG boost, lasso loss, lasso, SVR, which is support vector uh, regression, MLP, which is multi-layer perceptron. This program finds 4 top algorithms to ensemble and gives the output as those 4 algorithms and the R2 score generated. So here I got the best algorithms used for this ensemble were linear regression, XGBoost, lasso, and MLP. So I used these 4 algorithms to predict math score. So I got an R2 score of 0.89239 and an RMSE of 5.139, which is small compared to the values which were 50, 5, 60, 65, 44, and so on. And again, R2 score is pretty good, which is close to 1 as compared to the previous R2 scores. As you can see in these predictions, values like 60 were predicted as 59.72 or 65 were predicted as 65, which are pretty close. But there are again predictions like 44, which are predicted as 50, or 56 were predicted as 48. But as a whole, this model performed pretty well. As you can see in this graph as well, the red line here is the actual values or the actual math scores, and the blue line is the prediction values through the ensemble technique. And yeah, here finally I used a lazy regressor to see different algorithms and how what's your R-square values that they give. We got that the linear SVR value was R-square value was 0.9 and RMSE values was 4.97. All these algorithms couldn't be directly used in ensemble, and that's why I didn't use the top algorithm straight away from this table. I'll explain lazy regressor a bit. Lazy regressor is a Python library that provides simplified interface for implementing machine learning regression models. Lazy regressor can be a helpful tool for quickly exploring and comparing the performance of multiple supervised algorithms. Yeah. Conclusion: the dataset consisted of 1,000 rows with 8 columns. By evaluating a random state of 1 was using the features gender, race or ethnicity, parental level of education, lunch, test preparation course, and random forest algorithm resulted in a relatively low R2 score of 0.157. On including the features writing score and reading score in an ensemble of 10 supervised algorithms, from which 4 were selected, significantly improved the R2 score to 0.892 with a corresponding RMSE value of 5.139. And like I said, the lazy regressor gave that the best algorithm was linear SVR from the with the best R2 score of 0.899 and RMSE value of 4.97. This data set was taken from Kaggle, and I used this page for other references. If there's any questions, I'm ready to answer.
Right, Pratheek, are you done?
Yes, sir.
Okay, I thought there would be a thank you slide as well.
Yes, sir. It's a
Okay, right. So, right. So, can you just reshare the demo part first? Let's talk about the demo first. The Jupyter notebook. Right.
yes, sir.
So, see, there was a detailed explanation for every regressor you use. Can you just briefly explain all the regression methods you used in the Jupyter notebook. A brief introduction of all the regression.
Okay, linear regression is uses straight line fit.
Right.
It has a ax plus by plus c format.
Right.
Decision tree is I've already explained in the slide. Should I explain it again?
Yeah, this is just a brief.
Okay, it has it's a binary tree model,
Right.
which binary tree model which has a yes or no kind of a condition.
Right.
If it's yes, it goes to a single child node. If it's no, it goes to the other
Right.
child node.
Right.
Random forest is a ensemble of decision trees again.
Mm-hmm.
Gradient boosting, ADA boost and XG boost are boosting algorithms
Okay.
that just keep improving again and again the previous prediction.
Okay.
Lasso last is an extension of lasso regression. SVR is a support vector regression model again. It uses support vector modeling, and multi-layer perceptron is based on deep learning. It's simple. I mean, multi-layer perceptrons, different perceptrons are used.
Okay, that's fine. See, you were provided with a data set, right?
Yeah.
Earlier, because you in the conclusion you told like there were 1,000 rows from a given data set, right?
Yeah, sure.
Yeah. So have you shown that data set?
The data set first 5 rows I've shown here, and the
Okay.
bottom 5 rows.
Okay.
I didn't show all the rows.
Okay. Yeah, I thought there was, before starting the actual regression methods which are using on the data set, you should be actually showing the data set, whether how
Okay.
many and are there data, and then what are you going to do with them, and then start the demo part. So that
Okay.
would be more understandable, like not jumping on the method. First, show us what are you going where on what are you going to apply that method. Okay.
Okay.
Now, talking about the PPT, get back to the PPT. See, so there was a very good hook story at the start of the presentation. So we use good colors, and the formatting part is good. Themes which are using is good. It's just itself in this conclusion slide, as you can see, you are using 4 pointers, right? So have some space between them, or use them in 2 slides, so it won't look like congested. Okay.
Okay.
Rest, can you just scroll up? Okay, the pie diagrams are well good enough. See, the thing is, when you were explaining, so I believe there was some hindrance in your network.
Okay. Okay.
So at some point when you were explaining things, so it was like not audible, and it got not properly audible basically, right? So
Okay.
that's why I told you
Sorry for
to.
distance.
Yeah, that's fine. That's why I told you to just briefly explain all the regressions you are going to use in the
Okay.
see, there is good use of graph, good use of flowcharts, and you have created a PPT in a well structured manner. That's a very good point about this PPT. Uh, there are some slides where you have congested things, but you can improve on them. Good hook story. Lastly, the end part of the presentation was good as well. You talked about the reference and a good Q&A slide. So overall, the explanation part and the PPT both were good. That's all I have to say. That's sure. Right. So let's
Thank you.
sure. So let's move forward. We have Khalid Ansari with us. Yes, Khalid.
Am I visible?
Yeah, you're visible and audible as well. Please share your screen.
Sir, my screen is visible.
Yes, your screen is visible.
Can I start?
Right, you can start.
Good evening, everyone. My name is Khalid Ansari. and I'm from the Web Developers Group. This is a presentation on my task 2, which is overview of project Synopsis on the project real-time stock market data web application. Why I took this project? Basically, we were approached by 2 clients. One of them wanted to invest in stocks, but had difficulties in figuring out the situation of stocks and when it was the right time to invest in. The other client had invested in stock, but the company he invested was going at loss. The client had actually no idea about this downward stock trend when he actually invested it. And hence, by the time he found out and tried selling the stocks again, he suffered a loss of around almost 50%. Hence, and then the clients asked us to develop a real-time stock market data web application, which would help in investments and make understanding of stocks easier. Hence, this project was taken. Now, continuing with the presentation, this is a table of contents. We have introduction, key features, technologies, working of application, challenges, documentation, conclusion, and references. Introduction. Why we need real-time stock market data web app? Basically, this web app is a user-friendly online tool which provides up-to-date info about stock market prices and data related to it. User can search for specific stock or companies, view details, and monitor price fluctuations and make investments. With this application, investors, traders can remain informed about latest market trends, monitor their performance, and make time decisions. The key features of this application. There are 4 key features. First one, real-time stock market data. The web application pulls real-time stock market data from APIs and displays the stock prices, volume, market trends, and other info. It also has user authentication and security features. And easy to understand format. The data is organized and displayed in clear and visually appealing manner, making easier track of investments and analyze market trends. And then there is responsive design. This means that we can use it on different platforms like tablets, laptops, etc. The technologies used to develop this project. These are the technologies used. In the front end, we use HTML, CSS, JavaScript, and React.js. In the backend, we use Node.js, Express.js, and MongoDB for the database. And for the APIs, for collecting the stock market data, we use Alpha Vantage API. And for the news articles, we use News API. Now we'll go in detail about each. In the front end, we have HTML. It's basically, it is used to structure the web page. It's like basically the skeleton of the web page. Meanwhile, CSS, it is used to style and lay out the web pages. And JavaScript, it allows us to add dynamic behavior and special effects to the web page. Basically, it's like the brain. And then there is React.js. It's a JavaScript framework. It's used for building interactive user interfaces and web applications. And it has lesser code than the vanilla JavaScript code. And then backend. In the backend, we have Node.js. What is Node.js? It's basically a JavaScript runtime environment. It's cross-platform compatible, and developers use it to create server-side applications. And the main power of Node.js is fast processing of real-time requests in parallel. And it has a limitation too. It's only good for small applications with same light request. Then we have Express.js. Express.js is minimal and flexible Node.js web application framework that provides a robust set of features. It allows us to handle large amounts of traffic with ease, and it can be used to build a wide range of web applications from simple website to complex API. And for the database, we have MongoDB. It's a NoSQL database. It's a document database that provides support for JSON-like storage. It facilitates storing nested data that can be used to store complex data patterns in same document. This makes it easier to fetch data. For the APIs, we have used Alpha Vantage and News API. Alpha Vantage provides enterprise-grade financial market data and historical data through a set of powerful and developer-friendly data APIs and spreadsheets. Alpha Vantage API offers a wide range of functionalities, which include stock market data, cryptocurrency data, technical indicators, fundamental data, forex data, time series analysis. Meanwhile, the news API, the main use of news API is to search through every article published by over 80,000 news sources and blogs in the last 5 years. It basically allows developers to integrate news content into their applications, websites, or services. Now we'll see the working of the application. Basically, in the application, we'll have a home page where first we'll have to log in to authenticate. If we enter a wrong password or we don't have an account, then we'll go to the account verification section where we can change our password or verify through emails, or we can sign up and make a new account. After it is verified, and if the credentials provided is correct, we go to the page, the company information. We'll enter the name here. We'll name the company. We'll put the company's name, and it'll search for the company's stocks. And the request will be sent in the backend, and the stock market, and the API in the API stock market. The stock market data will be fetched from it, and the response collected will be sent to that front end, and it will be visualized. There are challenges in this project too. The main challenges of this project would be is to pull real-time stock market data from the APIs and display it in an easy to understand format, and to implement user authentication and security features to protect the user data. Now we'll have the documentation. So my documentation is visible. Excuse me. This is a documentation. This is the overview of project Synopsis of the real-time stock market data web application. In the table of contents, we have introduction, objective, key features, technologies, working of application, challenges, and conclusion. The introduction, as we have already introduced in the presentation, this is it. And the application uses APIs like Alpha Advantage API for real-time stock market data and News API for relevant news articles. The front end will be built using HTML, CSS, JavaScript, and React.js. The backend is built using Node.js, Express.js, and MongoDB for data storage and management. The objective of the documentation is to provide an overview of real-time stock market data web application project. It explains the purpose, features, and requirements of the project. These are the key features as we have already discussed in the presentation. Also, in the easy to understand format, we use charts and graphs for easier understanding. And these are the technologies used. HTML, this language is used to structure the website. CSS is used to design the appearance. JavaScript for implementing interactive and dynamic functionality. React.js used for building interactive user interfaces and web application quickly and efficiently with lesser code. And the backend technologies are Node.js, Express.js, and MongoDB. And the API technology. These are the now the working of the application. User interaction. User interact by performing actions like searching for stocks, access market data, and manage their portfolio. The front-end processing. The front-end sends request to the backend, and user input validated before sending. And the backend processing, it receives requests from the front end. After that, it interacts with the API, Alpha Advantage API, News API to fetch the real-time stock market data and news updates. And the backend processes and formats the data into standardized structure. And then we have the user authentication security. The backend performs user authentication. User login credentials are validated and authenticated. Technologies like password hashing, encryption, and secure communication protocols like HTTPS are implemented. And user authentication is achieved through technologies like authorization, JWT, which is JSON Web Tokens, or session management. And the data management is done by MongoDB. User credentials are stored in, and profile is stored in MongoDB. And the response, real-time updates continuously fetch from APIs and delivered to the front end. Response typically includes the extracted stock market in format, JSON-like format. And the front-end update, the JavaScript function on the front end receives a response from server-side function, and it updates the UI of the web application within the retrieved data. And the data is displayed in appropriate areas of UI. The challenges in the in this project are real-time data integration. The main challenge lies in integrating the real-time stock data from API into the application and also ensuring accurate and timely data retrieval, handle limitations of the API, which is like maximum of 5 API requests you can send in continuously, and then effective mechanism for updates. And then there is user authentication and security. This is also a challenge to implement robust authentication to secure user accounts and prevent illegal access, and also protect user data from vulnerable attacks. Now, continuing with the documentation, continuing with the presentation, we have our conclusion slide. The real-time stock market data web application is an essential tool for investors who want to track their investments in real time. The application will provide an easy-to-understand format that displays stock market data and other essential information to investors. And the web application will be developed using modern web technologies such as React.js, Node.js, and MongoDB. These are the references which I used. Thank you. Any questions? You can ask, otherwise you can contact through these details.
Right, Khalid, are you done?
Yes, sir.
Okay. See, 2 points. There was a good introduction, and the thing which stands out your presentation from the other which I've seen is the tree diagram which you showed, like the steps. I wish to mention whether people used to explain about the technologies, what they are going to use, all the front end, back end, then from where they are going to collect the real time stock data and everything. But they never talk about the steps, like actual outline of the outline design of their web application, right? Real time stock data application. But in this one, you had given a good tree diagram, like at least a rough idea about what how the application would look like, basic outline. So that was a good thing about this presentation. Now, secondly, there was good. Can you just scroll up?
Which one, sir?
Right. Scroll up. Right. From the previous presentation of yours, when you used to use paragraphs and everything, you have now improved using lines and which as the suggestions. So that's a good thing. Like you're improving on your PPT formatting as well. Your PPT look very well maintained, and good colors have been, good themes have been used. There was a well explanation of the technology stack and from where you're going to collect the data and everything. Then you create a separate document, which is a good thing, although that was not necessary because you already explained that in your chart, in a tree, like outlining the. But I believe the deliverable says documentation as well, right?
Yes, sir.
Right. So that was a good thing. And at the end, the reference slide and the Q&A slide was good as well. So in all, the presentation was very good and very well explained.
Thanks. Can I leave, sir?
Yeah, you can. If you don't have any general query, then you can leave.
Yes.
Or you can stay. Okay.
Okay.
Right. So moving forward, next we have lovely Pangotra with us. Yes, lovely. You can share your screen.
Hello, good evening, sir. I hope I'm visible and audible
Yeah,
at the
a very
same
good
time.
evening. Yeah, very good evening. Good evening. You're audible and visible as well. You can share your screen.
So I wasn't able to hear you. I guess there's some connection issue on my side.
No. Can you hear me now?
Yes, sir.
Yeah. You're audible and visible. You can share your screen. Right.
So, my presentation is real-time stock market analysis.
Okay.
So I'll be starting the task.
Sorry to interrupt you, but your presentation is not visible yet.
Okay, just a second, sir.
Yeah.
So is it visible now?
Now it's visible. Can you just start from the start?
So I'll be starting out with the presentation, real-time stock market analysis. The name of the task is overview of the project synopsis, in which we are asked to create an overview of the project. That's the full stack web app that's to be made to track the real-time stock market data in an easy to understand format, so that the user is able to visualize the stocks in a the value of the stocks in a very efficient and intuitive way. So this web app also has features such as user authentication and security. Moving on, this is the index. This is the overview of the presentation, the way the presentation will proceed. So introduction. So the web app that's going to be created is, first of all, I'll start out with the presentation. That's what's the main purpose of the presentation. The reason this presentation is made is for all diverse kind of viewers, ranging from the traders, the analysts, and all the normal users who can view the websites, because nowadays a lot of websites are available on the globe, and a lot of news articles are also made, but the user needs to get a website that's that has all the unique and all the latest and all the best articles, and also the stock chart should be up to date and real time. So this the reason the website was created. So what this website does is it takes all the real time charts, and it takes all the latest and greatest news and present it to the users. So we'll be starting out with the introduction, in which the web app provides investor and traders to the latest stock moments and the analysis, and also the news, as I already told you. So this is a full stack web app which allows investor to track real-time stock market in a very intuitive way. So we'll be using APIs such as Alpha Vintage API and News API to access the stock data and news respectively. So this is the web app that we created is designed considering the user in mind. So the features and benefits of the website are, it's real time. So whatever happens in the stock market is reflected straight out to the website of ours. And it's easy to understand, as we used line chart to demonstrate our stock values, and it's efficient search. So the user will be able to search the stocks and will be able to retrieve the value of the stock price as well. And user authentication is also ensured, as the user who has logged in is only the user who will be able to view the website. The other user who didn't log in into the website won't be able to view the website. So the real-time stock market data, it updates the live market updates of all the stocks, and it also has multiple markets, as in you can view multiple stocks after searching multiple giving the keyword of this stock index. And also it can give you a chart predicting the historical data, so that the user will be able to look into the chart, and he'll be able to see the duration in which the data is shown, and he'll be able to predict it. And using the prediction model, he'll be able to analyze if he has to put if he have to invest the money right now, or he has to wait some time. And he can also visualize the market activity using the stock data. So the tools that we use in the front end of our website are HTML is that's the building block of the website that'll be used to create the website, and CSS is just to style the website, and JavaScript will be used to make the website interactive, so that the user will be able to search it, and the website will be able to take it to the certain other page. And then we also used React, which is a JavaScript framework, and it helps to make the code very much easy to understand. shorter, and the user will be able to perform the same functionality of JavaScript with lesser code, and it's a very new technology, so it's a good one actually. So then will be the things that we use in the backend are Node.js. It's used for parallel processing. So a lot of data would be getting, and a lot of processing would be happening. So Node.js helps in the parallel processing, so that multiple processes would be able to run in the same time, and the user will be able to get the data faster and efficiently. And then Express.js is also a JavaScript framework. That's the main function of the Express is to maintain high traffic. That if the website in future receives high amount of traffic, so Express.js will be able to handle that traffic. So then we have MongoDB. It's a NoSQL database that helps in creation, deletion, and updation and retrieval of the data in a very efficient and high performance way. So the APIs that we used in the web app are news API. First of all, the news, all the there are a lot of articles on the globe that I actually already discussed. So the user doesn't know which are the best ones, which he wants to look into to get the latest and the best news. So news API is a very well-known API that has major outlets like CNN, BBC, New York Times, and these are very trusted organizations. So you'll be able to get the JSON format of the APIs, and you can actually just put a link into your website, and it'll be redirected towards the article itself. And then you also have Alpha Vintage API, which is a API used to retrieve the stocks information. So it also retrieves the information in a JSON format, and the developer nowadays what they do is they take the JSON format and they convert it into a line chart or a bar chart or any other kind of chart, and so that helps in the intuitive user interface, and the user will be able to look into the data in a different kind of way from which the developer actually retrieved from Vintage API. So that's a good thing. The user will be able to understand and look into the website in a very easy way. So this is the whole workflow of the website. First of all, the user will land on the home page. Either he'll type the address on the address bar, or he'll just click on the website link and he'll land on the home page. Then he'll be sent to a sign up page that's actually used for authentication. Once he signs up, he'll be asked to log in, and if the credentials are right, he'll be able to visit the website. Else he'll be asked to put the credentials again. So once the credits are matched, so he'll be able to use the search page, in which he'll be able to search the um, company's keyword, as in for Amazon, let's say it's AMZN. So he'll be able to search the stock of Amazon, and he'll be able to retrieve it using the Alpha Vintage API, and he'll be able to retrieve the data, and that could be visualized in the front end using the HTML, CSS, and JavaScript and React that we used in creation of the website. Then we have the challenges that we will be facing while the website is working. It's like handling large amount of data, and we are actually incorporating Express.js so that large amount of data could be handled. And data confidentiality and security, that's data authentication, that could be ensured by using sign up and login. And the user friendly interface is, if the designer and developer made the interface good, the user will be able to stick to the website. Else he'll just close the website and move to some other website. So, and also optimizing accessibility and usability. SRS document that we are actually asked to deliver. So first of all, the first of all, we'll start with why this SRS, because developing is not a single person's task. It's a task of a huge group. So if in the group, some person say thinks that the deliverables are something else, and the other person thinks that the deliverables something else. So that will make the whole work chaotic. So this the software requirement specification is this document that will ensure that all the developers are on the same page, that they are working on towards a single task, not on different tasks. So what this website is doing is it'll taking the news API in Alpha Vintage API. It's extracting the data from their APIs and it's displaying the user in a very intuitive way. So these are the abbreviations that are used. API is for application programming interface. That's News Vintage API and News API and Vintage API and SRS. This is the document that we are showing right now. Software requirement specification document that's used by the developers and can be accessed by each and every developer that's doing that project. So this is the way that the data can be retrieved from the Vintage API and can be represented in such a way. There are other ways of displaying data as well, but this is one of the way. So the website can integrate with external API to find a way. So all the website and traders who are interested in real-time stock market data can visit our website, can fetch the data, and can also fetch the news and the headlines that's used for stocks and all. So operating environment is the environment in which the website and the design should be user-friendly, and the user authentication should be kept in mind, else any user can use other users' data, and that's something we don't want. So we want our website to be authenticated and encrypted so that the user feels secure. And these are the functions and non-functional requirements of a website. Functional is a registration, login, that's for authentication, and real-time stock market data and news integration. So integration of news and integration of the stock data. And then it's the performance, how the website should be performed efficiently, then the security and the user interface should be very intuitive again. And these are the additional requirements. So like the user will be able to favorite their stocks, the stocks that they are interested in, and could also ask for notification. These are just some additional requirements. That's not the primary focus. And we'll be coming back to a presentation, and these are the conclusion. So the app provides a very powerful and visualizing real-time stock market data, so that the user is able to look at a particular stock and is able to get a particular stock data. And the user authentication and verification is also included in this very website. And this uses modern tools such as React, Node, and Mongo DB. So overall, this is a very valuable tool and could be used by anyone who's looking to stay up to date with the progress of the stock market. That's it. Thank you, sir. These are references, and any questions, sir?
Right, you are done, right?
Yes, sir.
Right. Lovely. Your presentation was scheduled on like 5th July, right?
Yes, sir.
So why the delay?
So the place I'm living in, so I have to shift because my entrance got over. So I had to shift from a hostel to a different place. So that took time, sir.
Okay, so did you informed in the technical chat support?
No, sir. But I gave the presentation, the PPT already, sir.
Yeah, basically you submitted the task,
Yes, sir.
but you have to inform if you are going to give presentation on a different date. You
Okay,
have
sir.
to inform in the technical support.
Sure, sir.
Right.
From
So okay. So talking about the presentation, see, can you do you know that today's real-time stock data apps have like this feature. If you don't like, if you have bought a stock, right, and if you don't want to continue with that stock, you can sell it, right?
Yes, sir.
So don't you think that feature is a good feature?
Yes, it actually is, sir. Yes.
Right. So I think you should include that feature in your. Don't you think that you should include that feature in your real-time stock data application?
The buy and sell app, sell stocks. Is
Yeah,
that what?
yeah. Because
So,
in your PPT, as I saw, like there were only real-time stock data application, right? And there were like how to get the real-time data and everything. So if it's a stock trading application, real-time stock trading application, so you'll definitely buy and sell a stock, right? So I believe that that was like an important feature, na?
but the thing is, sir, what our website does is it visualizes the data. It doesn't. It's not linked with the stock market. So what it can do is it can show you the chart. It can show you the prediction of the chart. So the user can look into the chart. He can see the prediction of the stock. He can see if the stock is going up and down. He can see that if he wants to sell or buy stock. After looking into our website, he can then go into some other website because that feature isn't available on our website yet. Yes.
Okay, okay, that will do. Okay, that's what I'm getting to you. Right. So talking about the PPT, see there were some slides where you used passages, but and there were some slides where the font size was too small and you didn't zoom while presenting them. Right. So that shouldn't be happening. You can
I,
either divide it into two slides or zoom it, or use a bigger font size. So that would solve the problem. And there was a good introduction part, but see, directly jumping on the main topic and not adding hook story is not good thing for the PPT. Right? You should start like with a good hook story first, and then go for the introduction, like as you did in the PPT. Hope you understand.
I okay, sir. I did say a story while before presenting the introduction, though.
I believe that was like the introductory part, because when you started with the introduction, you
Mhm.
talked about. Can you just scroll up to the introduction part?
That's it, sir.
Right. So
Just a second.
yeah, you started from here, right?
Yes, sir.
Right. So this was like a brief introduction of what you are going to build.
Yes, sir.
Right. So that was the introduction part when you start. But before that, why do you need, and like what was the necessity, what was the need that arrived for you to build this application?
I think I explained it. I'm not sure if that was very I mean explanatory, but I did explain that the traders and the normal users will be using the website, and the reason that this
Yeah.
website is made is because there are a lot of website available nowadays, and the user doesn't know which one to go to. So we have made a one-stop solution.
That's like related to the your task, your website. So like it's in the introductory part.
But I mean, what else can we use in the hook story circle? Like that's the
See,
reason we made
although
the
yeah,
right?
that's fine. Although it's like it's a synopsis, so you can't
Mm.
actually add a proper hook story. But something like in the modern age where everything like is just about the data stock. So why not have that feature as well, and then go with the your introduction. That can be added.
Okay, sir.
That's from my side. You can think of your right.
Okay, sir. I'll take care of
Yeah.
that in the next one.
Yeah. Talking about the PPT, as I saw that slide, can you just scroll down where you have divided into four compartments? Can you just scroll down?
Yeah.
Here as well, the font sizes are too small, right? And in the second next slide, yeah, this one as well.
This one.
Yeah, this one as well. See the workflow which we explained was very good, right? That was very well explained, and that's I believe that's all, because you included reference slide as well and Q&A slide as well.
Yes.
Right. So that's all from my side. Just increase the formatting part, font size, and try to add a different like hook story from next PPT onwards.
Yes.
Right? Yeah, I believe that's all from my side.
Should I stop presenting?
Yeah, you can. And yeah, please try to inform from next time onwards whether you're going to delay the presentation. Yeah, the date.
Yeah. Not to delay in the first place itself, sir.
Okay. Yeah, I believe that's all from my side. Do you have any general query?
Not really, sir.
Okay.
The thing is, I wasn't sure about that we had to create a website or not. Then one of my friend told me that we don't have to actually create a website, because in the deliverables, one thing mentioned is a fully fledged website, but that's something we don't have to do. So I was a little worried about that.
Because your topic is overview of project Synopsis. You don't actually have to build. You have to just explain the workflow, the flow of your website and the features that it contains. Because clearly. Let's wait for a few minutes for him to rejoin. Right, so I believe it's been quite some time now. I believe it's not joining. Right, so since we don't have any more presenters here, so we'll be ending our presentation session now. Right, a very good evening, everyone, and thank you.